Now, if you don't look at the face, the videos are identical. What happens is that in condition 2, in the head turning condition, at the end, before the video stops, she will look at the block that discontinues the color pattern. Okay. So this is what we observed in terms of eye tracking measures in children with typical development. And you will see blue dots. The blue dot is the child is looking at, and the bigger the blue dot, the more attention the child was paying to that specific area. Can we? How does it work? No, wait. What were the magic words you used? Turn on the video. Si può partire il video? Oh, wait. No, don't do it. This one. Okay. Child with typical development. Wait. This video, please. This is a typically developing child. He's observing the action. And as you can see, it's going back and forth from the face to the action. There's no need to look at the face of the agent here to understand what's going on. But typically developing children do this a lot. Now, this is what happened with a participant with autism. Can we watch this video? Okay. Now, at this point, as you can see, we don't see this back and forth from the face to the action. But what is interesting is if we look at the gaze to the agent's face, there's a significant group difference. But if we look at the performance here, there's no group difference. You can actually solve this problem. You can figure out that she's stacking blocks, alternating red and blue, even without referring to her face. So these are two different pathways here, and they will both lead to a good performance. In this condition, when the action speaks for herself or when the objects speak for themselves, you don't need that extra information. It's interesting that children, typically developing children, will look at the face anyway, even if it's not necessary there. Now, this is the second condition, the head turning condition, and this is a child with typical development. Can we see the video? Same action, but this time she's gonna turn her face toward that specific block. And let's see what happens with the children with autism in the same condition. Video, please. Can we see this video? Please. Again, same action, but she turned her head, he missed the referential cue. Again. So in this case, if we look at these two conditions in terms of eye tracking measures, what happened was exactly the same. In both conditions, children with autism are looking at the face less than typically developing children, and typically developing children are looking at the agent's face both when it's not necessary and when it's necessary to understand the agent's action. And in terms of performance, this second condition, the head turning one, was very difficult for our children with autism. And in fact, they performed 4 times worse than typically developing children. Only one child passed both trials. And it's, what we found is that the reason why they do not understand that she's going to pick up the block that discontinued the color pattern is because they did miss the referential cues. So here we found a straightforward correlation between missing the referential cue and not understanding the intention. If you look at that video without looking at the face, you're not predicting what's going on, and ultimately you're not understanding, you're not learning from that. And the second experiment involved another important kind of cognitive bias that children have and use to understand actions, which involve the expression of emotions. As we know, infants expect an agent to pick up an object that they are looking at with a happy, satisfied expression, rather than an object that they're looking at with a disgusted expression. So if I have these two objects and I'm looking at this one and I'm doing and this one and I'm doing children will think that I'm going to do something with this one rather than this one, okay? And so we use the exact same paradigm that we used in the previous experiment to test this hypothesis. Maybe children with autism would not capture the emotional cues. Maybe if I'm doing something like this, they're just not looking at my face, so they have no idea what I'm going to do with these objects. Or second hypothesis, they will not use such signals to understand and predict the agent's action. They will look at the emotions, they will get this information, but they will not use it functionally to figure out what's going on. And the same procedure as in study 1, they watch videos, the video ends before the action is done. And this is how the and participants are asked to complete the action by doing what they think that the agent would have done. And this is how the videos look like. The actor had two sets of objects, and if you don't look at the face, what she's doing is she's putting here some pencils here and some pens here. But what she's doing actually, before sorting and putting things here and here, she's trying to use these objects, the pencils and the pen. And she's pairing either a happy expression, like, oh, this works, and then she puts the objects here, or a dissatisfied expression. And what is clear if you look at the video is what she's doing, she's not sorting objects according to pens go here and pencils go here, but writing utensils that I'm happy with go here because they work, and those who don't work, and I'm showing this because I'm very unhappy, go there. You will understand this better when you see the videos. Our children with autism did understand somehow. And this is what a typically developing child did in terms of eye tracking measures in this task. Possiamo vedere il video? This is one trial. And this is another trial. Did you figure out what's going on? If you don't look at the face, you only see matching things. If you look at the face, she's testing things, and when she's happy, it goes this way. When she's not happy, it goes the other way. So participants were asked to complete the task. Now let's see what happened with children with autism. Possiamo vedere questo video? What happened with children with autism in terms of eye tracking measures is the exact same thing. They will look at the face a lot. These are both trials. These are the same children who did not notice a dramatic movement like a head turn. They're looking at the face now in this condition. And if we look at the gaze to face, there are no group differences here. If we look at the performance, children with autism are great in this task. They had a choice. They could systematize and they could empathize, and they choose to empathize. They choose to go where, according to the agent's emotions, rather than following a specific pattern that was based on the property of objects. So, my preliminary conclusions on these experiments, children with autism demonstrated to predict and to understand actions based on the object use and on things like color pattern or what the object suggests you to do, but also what we noticed is that emotional cue, the display of emotion, had a great power in attracting the attention to the face in these children with autism. So this, again, this is the same group of children. They ignored the dramatic head movement, and they failed to understand or to capture this very relevant referential cue, but they did notice the emotions that were going on, and they did use such emotional cues to understand and predict the agent's action. So a lack of sensitivity, which is specific to referential cues, such as head turn in these experiments, affected children with autism ability to read and intentionality and predict people's behavior. Now, the fact that that these children who were ignoring, who were paying attention to the object, as soon as a big smile on the face appeared, they look at the face, in my opinion, is helping. These data are helping more treatments that involve emotionally rich environment used to frame learning, so to capture children's attention and use emotionally simple but powerful cues to get children's attention and to frame learning. Thank you for the attention.